Now recording. So, exams are coming. Are you ready? Are you prepared? If you're too confident, that means you're not taking it seriously. So, lack of confidence is an asset. It means that you study. If you're too confident, you're like, I got this, then you won't study because you don't need to. But if you don't think you're gonna pass, that's when you study. Any questions about anything at all? No? Things are going well? How's the assignment going?
Good. Actually, yeah, a question about the assignment. It wasn't clear about like what you need the user to input and what you want to kind of not hard code, but supply to your Tim's order.
This is a good question. This is the second time I've heard that question today, so why don't we just take a look at the wording of the assignment then. Seems to be very ambiguous on that point, doesn't it? Okay. Oh, whoa, hey. That's not even, what? I hate it when people do that. Duplicate. Thank you very much. So, according to my reading, and I'm happy to have it out with you folks about this, talking about mug.create, which is the create methods of the objects, we can generalize that. Pardon me, the create method of the products that you're creating the individual classes for. Let us be precise in our speech. This method will have a dialog with the user to collect information about the object. In this case, color, comma, cost, and price. While it seems counterintuitive that you should be able to set your own price for things that you buy at a store, this is in fact, in my estimation, how this has been written. I believe this generalizes to everything else, including your own custom product classes. So yes, in coding terms, make it so the dialog asks for everything that is required to construct the object. Yes?
For like the mug color, for example, because color is a color object, if you have the user like type in, say, white, for example, and if you check the string and just set the color with the white, would you do that, or do you have to like decode with like a hex?
Ooh! Oh, that's nasty.
You probably have to do like a switch statement. Be like,
Switch for, like,
if this, then enter.
Okay, yeah, I will allow that. In that case, let's give the user a choice of a couple of colors, and you can use a switch statement to select the color object. There is a way of converting them. It's not impossible, but it's not really the point of the assignment. So I don't mind you saying, do you want your mug to be red, white, or chartreuse? Right? Questions?
So I already submitted the assignment, and I just left it, when it printed, it just prints the hex code for the color. You want me to redo it and resubmit it?
Let's just say that in the grand scheme of things, you're asking me if I think that's worth like an entire half-point deduction on this assignment, right? Because the assignment's graded out of 10, and in general, like, the quantum level for assignments is generally half marks. You guys know what I mean by quantum level? It's like the smallest individual packet of marks that I can give out is usually a half mark, right? So, or at least, like, there's nothing saying that's the case, it's just kind of conventional, right? So, would I deduct half a mark on a thing that's out of 10, right, for such an offense? Is it worth losing 5% of the grade for that assignment? Presuming the assignment is complete and secure and 100% otherwise? Probably not. Probably not, you know? Like, we should strive for completeness and, you know, meeting specifications in all respects, but, you know, 1 or 2 errors normally falls within the realm of forgiveness, right? Unless they're sort of indicated major errors, right? Like, the point of this assignment, well, okay, somebody tell me what the point of this assignment is.
Knowing how to use things like implement, inheritance and polymorphism and stuff.
Yeah, it's like now we have interfaces, now we have abstract stuff,
Interfaces,
right? Interfaces, abstract methods, that, all that jazz. That's like absolutely the main thing I'm going to be looking for in the assignment, right? Whether like you take the color as like a color object from JavaFX, or, you know, if you make it like a string, it's like, it almost falls into nitpicking for me, you know? It's a little bit nitpicky. The main point lies elsewhere, you know? So that's my perspective on it. Follow-up question.
Yeah, I mean, it does show, if you scroll down, the example to string right there, it does show the color as...
So it does. So it shows it as a hex code in the example. Yeah, so you have even firmer footing to stand on for it then, yeah. So, any other questions about the assignment?
Every class should be in a separate file.
Yes, yes, absolutely. That is convention in Java programming, is that every Java class should be in its own separate Java file. I realize this makes them a little bit of a pain in the butt to upload to Canvas, because you have to like drag them over one at a time.
Just I'm asking because, you know, in one of the past assignments, I received feedback from the instructor. He told me, you created so many files. I was keeping every class in a separate file, especially the total. I'm talking about the total assignment.
Well, I can't really speak to how things have been graded by previous people in the past. This was Gilbert, right? Was this Gilbert who was teaching this? Yeah. Really? You had a problem with like everything being in its own file?
Because the turtle has a head and a tail and a body, so I kept every class in a file, a separate file.
Personally, I think it demonstrates modular thinking, which is one of the things that you should be working towards. So I personally have no problem with it. In fact, I would encourage you to use many small files. When I do development work myself, I always try to have many small files. Big files are bad. Good small files are good in general. So no, I'll certainly not give you any marks deduction. Like, did he deduct marks for it, or did he just complain about it?
1 mark.
Oh. Well, I can't speak to, I can't, you know.
Yeah, he didn't do that, so.
Yeah.
I mean, we all produced the same amount of, I would have called him out on that.
I promise I won't do that to you. I can't speak for the past, but I promise I won't be back.
Just to make sure that it's okay if I create this, if we pass in a specific file, okay?
I give you my blessing.
Thanks.
Any other questions?
Last question.
Oh, sorry,
Sorry.
this fellow back here and then you again?
It was more of a comment. Last assignments, we didn't have to submit the text, the .text file. It was just the zip file.
Yes,
And for
that
this
was annoying to me.
one, maybe that's where the difference,
Has anybody actually submitted this thing yet?
yeah, I did.
Did I fix it? Let me see if I fixed that. Oh,
You're allowed zip. Oh, you do want TXT files.
I want TXT files.
Do you want not, you want the zip as well, or just TXT?
Just TXT. I have a whole system for it. I do a bulk download of everybody's TXT files, which have been pre-pended with your names. I then use a bash script to sort out whose is whose, pull it into a temporary folder, and then mark it from there. So yes, I don't want it in zip files. Gilbert.
I mean, I do have to resubmit the exam to change the mod class.
Did you submit it as a zip file?
I did both.
Okay,
The
well,
zip file and the
just TXT, please. I think that doesn't invalidate submissions that have already been made when I do that. It's just like, from this point forward, anybody who submits must do so in the form of a TXT file. Several TXT files, please, thank you.
The extension of the file should be Java or TXT?
Here's, yes. One of the things that my bash script also does is corrects it when people get this wrong. Class name .java, right? This is your Java file.
Yeah.
The correct naming,
Okay, just that.
you just add it. Yeah, you append the new file extension. So you have .java.txt at the end. But you know, I've been doing this long enough to have built a script to fix it when people do that incorrectly. So it doesn't make as much difference as it used to, for me at least. Yeah. Any other questions about the assignment? Yes.
Should it be output to a printf statement? Should we use printf statement for output or should we use going?
Oh, no, this is a console. Everything should go through the console.
Okay.
System.out.println. Yeah. Or printf, whatever you like. Yeah. I would be impressed if anybody uses printfs actually. Question?
For, I noticed assignment 6 there was unpublished, is that due next Friday then?
Yes. In fact, let's take a look at it right now.
I noticed it was tri-catch.
Yeah. So it's kind of another one of these you know, do something in Java FX kind of assignments. There goes the Chrome. There it goes. This one's a little bit more open-ended. If it would load, thank you. Oh look, yeah. So let's go through assignment 6. The stuff in this is stuff we are doing today, but I want to make sure we have time to go through it, so we'll start here. So, the focus of this assignment is mouse listeners, exception handling, and array lists. This assignment will also require the use of encapsulation, association, inheritance, and polymorphism. In this assignment, you will create a very simple drawing app. The app you create must be capable of drawing 2 different kinds of shapes on a canvas. The 2 shapes should inherit from a common superclass. You can use square, circle, and geometric object classes as given in lectures, or you can create your own. The user must be able to configure the parameters of the shapes, and must be able to draw it by pressing a button or clicking or dragging the mouse on the canvas. So, below is a UML class diagram for the code you are given for this assignment, minus the Paint app. Here it is. So, you are given this code in a zip file. This is what you're designing. You'll notice that in the UML, you've been left, your variables go here. So, the Paint app is yours to create using the FX graphics template, our well-trodden FX graphics template. You can adapt it as you wish to suit your needs. At the very least, I would expect most people to resize the window. You'll need to add new lines to throw exceptions if the user tries to create a shape with, if it's out of range or with null parameters. So essentially, the concept here is you will do a drawing app where the user enters some parameters about the shape they want to draw. If those parameters are wrong or wouldn't work, the thing tosses up an exception, which it then handles elsewhere, right? So, yes. You don't have to hand in a class diagram, but you do have, and you don't have to implement what is shown below exactly. In this example, Paint app would store shapes in an array list, geometric object. Yes. So, performance basics. The screen capture below shows a very bare bones version of the application. Your application should not look exactly like the one below. You should try to put some thought into what would make it attractive and usable. So here is what it might look like. You have a region. Why do I insist on the markers when I have better equipment? You have a canvas region on the application. This is what's used to put your things on, right? You have buttons selecting circle or square. You guys could do other things if you want. These are like the basic shapes, right? Location, size, color, draw, undraw, right? So using the draw button, you can get like one square or one circle to print itself to the screen. The idea is, using mouse events, you can click and drag, and as you're clicking and dragging, the thing is creating a continuous stream of objects, which then allows you to paint a pretty picture. Make sense? You can also see at the bottom of the window here, there is a status bar which indicates errors. So when, for example, if you try to select a color where one of the values exceeds 255 in this example, right? That's an invalid color. You would get invalid color appearing upon the status bar rather than having the program crash. Make sense? And rather than handling this with if statements, the thing that we're trying to get away from in this application is validation using if statements. We want validation, like yes and no, right? You'll still need if statements, like if this color value is greater than 255, do something. The thing that we're trying to get away from is like returning falses and that sort of thing. We want to integrate the exception handling in Java to throw exceptions up when these error conditions occur. Does this make sense so far? It's not nearly as difficult as it seems. This looks intimidating, but it's actually not too bad. When the user presses the undraw button, it removes the last shape drawn from the array list, and then clears the canvas and redraws everything to remove the shape. It should be possible to keep pressing undraw and remove shapes until the canvas is empty. So it's kind of like an undo button. It should be possible for the user to trigger exceptions. When the user clicks clicks on the canvas or drags the mouse on the canvas, any possible exceptions, badly formatted fields, out of range color values, etc., should be caught, and the user should get an error message in the label that specifies 1, the name of the field that caused the error, and 2, the nature of the error. For example, if I put 360 here, that's greater than 255, that's an error. But if I put the word potato, that's a different sort of error, right? So it should have a different sort of error message. Does that make sense? Good. When the user successfully draws a shape, the error label should read no errors or something similar. The color of the label should change to indicate errors versus no errors. Optional extras. So that's the basic, those are the basics, that's what the basics need to be. Yes?
So for like the error handling there, let's say like in the first color section you can do like 360, the next one you do a word, and the third one you do like a negative value. If you fix one of those errors, will the other two errors not go away? Like, do you get to render that somehow?
For our purposes, and just because this is kind of how exception handling happens in general, I'll be fine with it showing one error at a time.
Okay.
It would actually, like, now that I'm thinking about that question, might be a little bit tricky. So essentially, let's say you have a method that's going through the routine of reading all of these fields, right? If you throw an error in that method, it is the same in effect as returning from that method, right? Which means that nothing else in that method executes, right? The alternative to that would be to do something like this. Try if condition throw exception. Catch, etc. Right? If you're raising an error and then catching it inside of the same method, it doesn't break you out of the method. It would continue on past that point. But that's really not the point of exception handling. Right? The point of exception handling is not to be a slightly more complicated way of doing an if statement. The whole point of it is stack smashing, actually. And I will explain what stack smashing is when we, in a few moments when we talk about exception handling. But this is like a rookie mistake kind of territory. When an exception occurs, the currently executing method should terminate immediately. Okay? So, yes.
I guess kind of leads to like another question along those lines is, if like after I type in say 360 in that first box, do you want the error to show up, or do you want to fill out all 3 boxes and then click draw, for example, and then it checks it, so that at least one of your values is incorrect or something? Because that would be like the easy way to kind of cheat around that a little bit and simplify it, but.
I'm okay with either way you want to do it. There's more latitude in this assignment than in previous ones. Either way is fine. So, optional extras. Basically, there's a lot of extra stuff you could put into this. I, understand that all of this is optional, so please be very confident that the amount of studying you've done for your exams is adequate before you pour a bunch of time into this assignment, given that it's in the final week, right? But the sorts of things you could do: add more shapes. You might be thinking, well, what other shapes are there? Line is a good one if you want to add something. Set colors using a color chooser or some other method. Set the location fields with a mouse click. Clear all shapes. That's a good one, actually. That one, that's easy, so most of you should be able to crack that one off with no problem. If you can undo one, you can undo them all. You just undo one until there are none left.
Move to the array loop.
Exactly. Precisely. And then just put a button in for that. Boom. Done. Highlight error fields by changing their colors. Add effects to the drawing, gradients, reflections, etc. Allow the user to click and change objects. That one's a bit harder. Allow the user to control click and drag to draw and size at the same time. You could just do other stuff, Documentation standards as per usual. Evaluation as per usual, given that there's no UML diagram to submit. Any questions about assignment 6? Okay, good. I love it when there are no questions. That's not true. If there's one thing I love, it's taking a question and turning it into a 20-minute digression. So, on to our material for today, for this evening. Does anybody even have the textbook? Has anybody been doing the reading? Have you?
I have like the e-text. I haven't been doing all the readings now, but it helps.
Have you been doing the reading?
The occasional one.
I'm always curious to know if anybody's actually doing any of the textbook readings.
It helps a lot. Like
Yeah.
a lot, yeah.
Well, there you go, folks. The textbook has been endorsed. Would you recommend it for studying for the exam?
Oh, 100%.
Yes.
There you go. All right, folks. If you were wondering, the textbook is helpful. So, catching exceptions. All right, so I somewhat cavalierly, at the end of class yesterday, said, I can teach you exceptions in 2 minutes, and then I showed you what one looks like. But of course, it's a little bit more complicated than that. So, hopefully we all know what a syntax error is. Hopefully we all know what a runtime error is. Logic errors are something a little bit different, right? So errors kind of categorize into these 3 camps. By the way, not all pre-runtime errors are syntax errors. Some of them are type checking errors. But generally, you have errors which occur while you're compiling, errors which occur while it's running, and then errors which don't cause an error but are still errors. These are generally known as bugs, right? So, exceptions are runtime errors. Pretty much every time you've had Java give you an error while something is running, something has thrown an exception. In Java, because object-oriented is the name of the language, or it's the name of the day. Exceptions are objects in Java. This is true in many object-oriented languages. Exceptions are thrown by a method that gave rise to the error. The calling method can throw it onwards to its calling method, or it can catch and handle it. So, now for the fun part. Let's talk computer architecture. Do you know what the system call stack is? Anybody? All right. So, have you ever wondered how methods are called? How does it work? How does the computer call functions? Well, this is how it works, folks. Within the architecture of the computer, there is a section of memory which is called the system call stack, or just the stack, sometimes reverently the stack. So, in order to understand the system call stack, we must first understand what a stack is, right? A stack is an elementary data structure, a very simple data structure. So, a kitchen analogy, all right? So, in your kitchen, all right, most of you will have a cupboard, and most of you in that cupboard will have a stack of plates, right? So, when you require a plate for the food you are eating, where do you take the plate from?
Top.
The top of the stack, yes. When you clean a plate, where do you put the plate once it's clean and dry?
Top.
Onto the top of the stack. So, this is what a stack looks like, right? This is a stack of integers. If I push 7 onto the stack, it pops a 7 onto the top of the stack. If I pop a value from the stack, it returns 7 and it deletes that top item from the stack. It's kind of funny, in like the kitchen context, probably most people only use like the top 20% of the plates that they have stacked in their cupboard, unless you have a large family, right? So push and pop are essential operations on stacks, right? You'll hear push and pop as, like, once you get into more kind of data structures territory, push and pop will be words that you hear quite a lot. It generally means add to a data structure in a structured way and remove from a data structure in a structured way, right? Another name for a stack is a last in, first out buffer, or a first in, last out buffer. Those are actually the same thing. Okay, so that's a stack, right? So the way that programming languages use the concept of a stack to organize functions is this. When you are executing a program and a function happens, a new, what's called stack frame for that new function call is created, and pushed onto the system call stack. So let's say we had a Java program class main, right? Let's say we had a public static void main in there, right? Let's say this calls foo. Let's say this is like a very pseudo-codey way of doing it. Let's say that function foo calls function bar does nothing important for this example, right? When we load the program, on the system call stack, the first thing that we create is a stack frame for main. Right? This is the region in memory where main's variables are stored. All right? When you're thinking about local memory, this is it. This is actually, this structure of the system's call stack is what gives rise to our concept of global versus local variables. Because this is where local variables are stored. Global variables are stored down the stack, or sometimes in another memory segment called heap memory, but we don't have to worry about heap memory, right? Global. So, we're executing main. We hit foo. We have a call to foo. This creates a new stack frame for foo. Which means that foo gets its own new local context for its variables, right? It's separate memory from main. This is why in main you can have a variable called x with some value. In foo you can have a variable called x with some different value, right? They are in different regions of memory. They don't interfere with or talk to each other in any way, right? So foo executes, all right, down it goes, down it goes. It calls bar. What happens? Well, the same thing. A new stack frame is created for the execution of the new method. Bar. Bar has all of its own local variables. It has its own local variable space, right? Let's imagine it has, y is equal to 100. Who knows? Who cares? Right? It has some local variables. Let's say that at the end of this, bar returns y. So what happens when a variable, what happens when a function or a method finishes, terminates? It looks down the stack one level. It writes its return value into a spot that this guy left it, and then the stack frame is popped from the system call stack. And that's how functions actually work. Does that make sense? So, I imagine probably a few of you have used Stack Overflow before, right? If you haven't used Stack Overflow, it is an excellent resource for obscure programming problems, both non-obscure and obscure programming problems, actually. Extremely good resource. It's patrolled by a legion of the most highly expert people that you could possibly imagine. always doing the upvoting on good answers and doing the downvoting on bad answers. And normally, information that you receive from Stack Overflow is highly reliable and will often fix the problem. Normally, the problem that you have with Stack Overflow is like your problem is slightly different from the one that you're reading the solution to. That's normally the problem. But Stack Overflow, that is a type of error that happens with the system call stack. That's where the name of the website comes from, because it's an extremely difficult, well, at least historically, it's been an extremely difficult error to diagnose. It's like the mother of all bugs, because it's like your program is going and going and going and going, and then blue screen of death, right? Much of the time, the blue screen of death was because the stack ran out of space, right? Stack Overflow, if you will. That's where the name comes from. Any questions? Does that make sense? So, let's put bar back up on there for a second. So, all right, so why am I telling you all of this? This is the correct context in which to understand what an exception is and does. All right? An exception is a stack smashing event. All right? I'm gonna make this a little bit more detailed. So the thing that is running main, anybody care to guess? What's the process that runs main in Java? The JVM, that's right. The Java virtual machine is the thing, that is the frame upon which your main function rests. Does anybody care to, I don't expect anybody to get what the JVM is sitting on, but can anybody care to guess what the JVM is resting on? What launches the JVM?
Java runtime environment.
Well, the JVM is actually what you're downloading when you download the Java runtime environment. So, yes, anybody? Any guesses?
The kernel?
That's a good guess, but you're too far down the stack.
Okay.
So, for us in this class, most of the time that's IntelliJ, right? The IDE, right? IntelliJ is the thing that's running the JVM. When you press the play button, it launches the JVM launches main calls its methods, right? So here's another question. What's JVM, what's IntelliJ running on? The OS, yes. So within operating system theory, we would call this a shell, right? The shell. So shells are like, they're a bit different depending on what operating system you're talking about. If you're in Windows, it's like your Windows desktop environment, roughly speaking, right? In Windows, you generally think of things as having only one shell, right? If you are in a Unix/Linux/Mac OS based environment, Mac OS is Unix based, by the way, in case you didn't know that. It's in the Unix family of operating systems. In those environments, you will have a desktop environment, a desktop shell, but you will also have terminal sessions. Each command line interface terminal session is its own shell, in fact, you know, if something horribly wrong goes, if something goes horribly wrong with like a Linux distribution and it can't load its desktop environment, it will give you its command line environment instead. And then you can do all of your work from strictly command line, which is, you know, normally your work at that point is getting your desktop environment working again. But yeah, so shell. And then the shell runs on a thing called the kernel. Right? It's like a nut, right? You've got the shell, and then you've got the kernel inside the shell, right? That's where the naming comes from. And then, does anybody know what's underneath the kernel?
Hardware?
That's right! The hardware is underneath the kernel, right? And what's underneath the hardware?
Electricity?
Yes! Physics! Physics is underneath the hardware. Everything runs on physics. So, that's how your computer is organized, right? So, let's say, just for the sake of interest, bar throws an exception, right? Bar throws an exception. The behavior of an exception is to smash through the call stack until something catches it, right? So, if the exception occurs, it will smash, 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 smash. If it's unhandled by any of your code, the JVM itself will catch the exception before it hits IntelliJ or the operating system. IntelliJ is unnecessary, by the way. You can run the JVM directly in a shell, obviously, right? So the exception up here will break the whole program. This is the behavior that you've seen already 1,000 times. When you try to access an index of an array that doesn't exist, you generate an exception up here that goes unhandled, unhandled, unhandled. It breaks the whole thing, right down to the virtual machine itself, right? So, when an exception goes unhandled, it is very similar to returning a value from the method. It's very similar to returning. The only thing is, the thing that it has returned is a nuclear hot potato, right? That somebody needs a catcher's mitt for. So, you know, the exception generated here acts as a return statement, returning an exception to whatever's beneath it on the call stack. This thing now has an exception to handle. If it goes unhandled here, it does the same thing. It returns immediately, passing the exception to the next layer. If it's unhandled here, it exits immediately, passing the exception to the next layer. Once it hits the JVM kind of has like a global catch for everything before it hits the operating system, right? So, or the shell program, and then the shell, then the operating system. By the way, this is generally what's called an operating system. The shell plus the kernel. Does that make sense? So, because like a thing that people think about, or a thing that people generally don't think about, is like, when people write routines for exception handling, they will design it so that an error is caught like one layer down here, right? But in actual fact, you can as long as you handle it anywhere in the stack before it hits the JVM and kills your program, that's actually fine, right? It depends like how much of your program you want to abort in the event of an exception. But you don't have to handle it in foo, right? You can imagine a situation where you had 20 stack frames on the stack, right? It doesn't have to be handled Here, it can also be handled at anywhere before it hits the JVM. Does that make sense? Any questions? All right. Good. If it were up to me, like, you'd be taught that as soon as you were introduced to functions and programming fundamentals, because like that's how they actually work, you know. Anyway, so please pull up IntelliJ. Let's get a Java project up and running. We will do a couple of examples of catching and throwing exceptions. Insubordination! The machines are rising up. So, within your IntelliJ project, please create a new Java class called a new Java class called main. There we go. Throw a main method in there. Oh. Not main. There we go. So, I don't know, maybe as a bit of exam review, let's write a simple interaction. All right? On a scale from 1 to 10, how many starfish are in the sea? Scanner input is equal to new scanner system.in. Oh, and by the way, at the beginning of this course, we kind of said just memorize this because you don't know what you're talking about yet. Hopefully, by this point in the course, this makes a lot more sense than it did in week 1, right? Integer starfish is equal to input dot next int. There we go. If starfish is less than 5, S out. You are dramatically underestimating enemies. Goodbye. They destroy coral reefs, come on, when they get overpopulated. Starfish are the enemies. If you don't believe me, go look at pictures of crown of thorns starfish. Nasty, nasty little buggers. So, let's run it. Or maybe I'll just give you guys a moment to get that in. So, if we execute this program on a scale from 1 to 10, how many starfish are in the sea? 6. Goodbye. Fine. But what if I say, for example, you're not the boss of me? I get an exception. We cannot interpret that string as an integer, so an exception is thrown. It'll even tell you what type of exception you get. Input mismatch exception in this case. So, this line is a known point of failure. The thing that we now do with known points of failure is we wrap them in error handling. Error handling looks like this. You take the code that might fail, you put it inside of a try block. Catch exception E. That will do for now. Very good. Well, don't blame me when they conquer humanity. Cannot find symbols. Yes, okay. So, I've run into a slight error. But it's an interesting error, so we should discuss it. Cannot find symbol starfish. Here, you'll see starfish is now in red.
Out of the scope now.
That's right. What kind of scoping does Java use?
Block scopes here.
That's right. We use block level scoping in Java. This counts as a block. So this integer is actually at this point local to the try block. In order to fix this problem, and I can't help but think, oh my goodness, this would make a good exam question. You just have to declare it in its, one level up, if that makes sense. There you go. Question?
You still have to initialize it, the if block like that.
Oh yeah. True. There we go. So, on a scale from 1 to 10, how many starfish are there in the sea? I don't know. 2 maybe? Well, don't blame me when they conquer humanity. Question?
Why is it that in the middle of the try and the catch for mine starfish is equal as an error?
That's because you're redeclaring it. You need to delete that int right there. So, we execute this, an exception occurs, we immediately jump to the catch and execute it. Thank you for your cooperation. Let's run this again. If I do not cause the exception, we get through the next int line, we execute the next line, thank you for your cooperation, and then we do not execute the catch block. We jump over it to this if statement and continue the program. Does that make sense? So the catch block only executes if there's an error, and if there is an error, you'll notice that the output statement that's currently missing here is this one. Thank you for your cooperation. When the exception occurs, the try block is immediately stopped. As soon as the exception occurs, the rest of the try block is not executed. Instead, we jump to the catch, execute the catch, and then continue with the rest of the program. Does this make sense? So, really, exception handling is kind of just a fancy if statement, right? Instead of having a condition listed here, the condition is always, does an exception happen in this block? If so, we execute this and move on. Sound good? Any questions? Does everybody feel they have a good handle on the concept? Yes?
How to print out what type of error happens or exception?
Excellent question. That is what this thing is for, right? So you'll notice that the catch block is taking an argument. The argument it's receiving is the exception object which we have thrown. We can view details of this object. You see all the properties we have. Fill in stack trace, get cause, oh, there you go. Get localized message, get stack trace, get suppressed. Essentially, a lot of this is the information that you have already seen in this pane when an exception happens, right? And hopefully, since we talked about this, everybody has some kind of vague idea what a stack trace is now, right? Anybody care to guess what a stack trace is? We talked about tracing and we talked about stacks.
It's the path of the explosions as it goes down the trail.
That's right! It's the path of the explosion. That's what you were going to say, right?
Well, not specifically, but
So, get stack trace then. Let's try that one. Oh, it's one of those.
Yeah, I think append to string.
Yeah. That is the toString. I think it's an array, so you'd have to like loop through, I think. Yeah, there you go. There's the first level of the stack trace. To get all of them, you would do something like,
For each.
for each, or you'd loop through them. Another one that you can do is e.message, get message. No, it's null actually. I think there's one that's like just get all the data. Get localized message. No. The data is there. The data is it's contained inside of the E object. Yeah. So now let's allow me to demonstrate how to handle different types of exceptions within the same try block. This is also something that's very useful. So everybody remembers their subtype polymorphism? There's a diagram here. There we go. This is a neat little diagram of how exceptions, what the inheritance structure of exceptions is. This is a subset of the exceptions within Java. So everything inherits from object. Throwable inherits from object, provides a couple of methods such as print stack trace. Or get stack trace, I think was the one that print might just print it. That might be useful actually. Exception. You'll notice when we wrote catch exception E, that's the exception. That is the supertype of all of these different types of exceptions. Number format exception, illegal argument exception, that was the one that we were using, input mismatch exception, arithmetic exception, that's for div 0 and that sort of thing. All of these things, well, some of these are also runtime exceptions, but they are all exceptions. So when you say this handles exceptions, remember the rule. Anything of a subtype can satisfy a supertype. So all of these different exception types are handled when you say, I just want to handle general exceptions, please. Does that make sense? Fits in with existing rules? That is actually the reason that we haven't been able to talk about exception handling until the extreme end of the course. It would have been useful earlier in the course, but how you use it actually requires some knowledge of subtype polymorphism. Right? So, at least properly. Java's kind of an interesting language because there's not really any good point of entry into the Java language. Everything requires some abstract theoretical object-oriented knowledge. Pretty much everything, but anyway. So, for example, let me modify this. Let's say we have a string array messages. Terrible, bad, okay, good, and excellent. And let's constrain this so that this is a scale from 0 to 4. And let's say that the whole point of this program is that we are printing a message corresponding to the number which was entered by the user. Does this make sense? Question?
Can you zoom in a little bit more, please?
Certainly. Better? So, we have an array of strings. Here, we are outputting a message corresponding to the selected starfish. What happens if we enter a value that is not inside the bounds of that array? 3 guesses, given the topic of the lesson. Well, would it catch this? That would just be an unhandled exception. In order to handle the exception, it needs to be inside of a try block. Right? So, that's a problem. That will cause a problem. So, if I enter 2, I get OK, which is fine. If I enter 4,382, I get index 4,382 out of bounds for length 5. Boy howdy, is that right? So, this is a statement that could fail. We therefore want to put this inside of a try block. But maybe we don't want to build a whole nother try block just for this. Maybe we want to put it in the existing one. Because really, there's no point in trying to access this if the value that was entered wasn't even an integer, right? If this isn't even an integer, like what's the point in even trying, right? So we should put that up here because this line, being in a try block, guarantees that you didn't get a string in here, like, right? If you're here and you manage to get here inside of a try block, that means no exception happened. So you're safe. This must be an integer. Make sense? Good. So, in she goes. Very good. On a scale from the fun. It says thank you for your cooperation, but we get our message in our catch block. We print the nature of the error. It's an index out of bounds, array index out of bounds exception, right? So here's a question. Maybe we want this to do different things depending on what type of exception has happened, right? Array index out of bounds exception. Custom error message for this particular type of exception. exception here. We are permitted to have multiple catch statements. We are permitted to have multiple catch statements corresponding to different types of exceptions. Let's see how things work if we run that. So, if we enter a bad string, we get this one, well, don't blame me when they conquer humanity, which is the error message inside of that catch block. Very good. If we enter a bad number, you'll notice, that's a very aggressive number you have there. That gets printed. This one doesn't. The way to think of these catches, you should think of them as analogous to if-else blocks. With an if-else block, you never execute more than one of them, right? You never execute more than one branch inside of an if-else block. The same thing with catch blocks. You never execute more than one catch block. Another property that this shares with if-else blocks, in an if-else block, you always execute the first condition that matches your situation, right? In catch blocks, you always execute the first block that matches the exception that you gave. For example, if I reverse the order of these, if I reverse the order, there we go. Haha. It even gives me an error. It says, exception, out of bounds exception has already been caught. Interesting though, is that like that's a red squiggle, so that's an actual compiler error in Java. Java really cares about you. It really cares, it loves you. Java is a language that loves you because it's trying to protect you from your own stupidity. JavaScript is a language that hates you because it is not trying to protect you from your own stupidity. So essentially, will this even compile? I don't think it will. That's an actual honest-to-goodness error. Very good. Good job, Java. So, exception is the base class for all exception types. Once you've handled all exception types, this cannot ever be executed. Java knows that, and it's giving you a compiler error. Make sense? Good. So when you're doing try catches with multiple catch blocks, this guy at the end here, handling a general exception, he is analogous to the else at the end of an if-else chain. This is the catch-all, right? Any type of exception that you haven't specified explicitly here, that will be caught here. Does that make sense? Good. Any questions?
Now the array index out of bounds exception is a class,
Yes.
so we can generate our classes of exceptions.
Oh yes.
So we can create custom exceptions.
Oh yes. You can actually even like define your own exception classes inheriting from exception classes if in your program you feel it's necessary to have exception types that Java doesn't provide by default. You can even go that far. Using the power and the magic of inheritance. It would go something like this.
Then we might need it in the drawing application.
You shouldn't need to define your own exception classes. You should be able to get by with existing exception classes, especially because you can just throw a general exception, right? But here, my custom exception.
Extend exception.
Right? And now, I don't think we even have to add anything to it. We can, if this works, then everything works. Catch my custom exception. What's your problem? Ha! Sure. It's doing more checking. Java, you are a stern but fair tutor. So, the complaint that it's making is not that this exception doesn't exist. The complaint that it's making is, that block doesn't throw this. Why are you asking for it? So, let's throw it. Exception throwing. It's very simple. Throw, new, my custom exception. That's it. So this is slightly different than exception handling that you will see in other languages, mostly because of the necessity of including the new keyword. Remember, the new keyword is the thing that we use to create an object from a class. This throw expects an exception object, not an exception class name. So, in Java, you must take the class name, create an object from it, and then throw the result.
No need for constructor here.
This is the constructor. Yeah. Yes. Here's an interesting thought, though. Ha ha ha. So, let's let me undo that for a moment. Let me show you that again. So, I apologize that this is a bit small in the back for you to read, but if you alt insert inside of the exception class we just did, you'll be able to see this menu. These are all of the available exception constructors inside of the base class exception. Most notably, you will see exception message string, a constructor that allows you to pass a string as a message to the exception, presumably for the user if the exception goes unhandled. So, if we throw that in, it's now complaining that we're not providing an argument here. This is a custom exception. I'm presuming get message will show that. Boom. So to get there, we have to enter everything else validly, right? It's kind of a stupid try block because, like, if this works and this works, throw an exception anyways, right? But, you know, it's for teaching purposes. And there you go. Thank you for your cooperation. Good, that's the output from this line. We then throw the exception, jump to this catch block. Java, you are a stern but fair tutor. And then e.getMessage says this is a custom exception. This is a custom exception. There you go. So that's how you throw exceptions. You don't, by the way, this works for just exception as well. Right? Make sense? That's where it's deriving all of this from. So, if you don't know what other type of exception to throw, you can just throw exception itself. Right? In general, though, like, let's just say if there was a senior Java dev looking over your shoulder and you just threw exception without, like, you know, saying what kind, he'd probably be like, surely you can provide more useful information than that, right? So yeah. Does this make sense? Any questions? Yes.
Sir, will the catch exception cancel out the custom exception you made?
Like if I put this one below that one?
Yes.
Yeah, you'll get the same effect, right? Both of these types of exceptions are inheriting here. So yeah, I'll show you, but I'll get another compiler error that says that that one's basically unreachable. Has already been caught. Good question, thank you.
So thanks, we can use that for any custom exception we need.
This one?
Yes.
Yeah, this, again, catching just exception, you should think of that as your else block or your default block in a switch or something like that. If all else, like if nothing else matched, this is the one. Does that make sense? It should always be the last one in the list as well. Any questions? Very good. Let's see. It's about halfway through, so we should probably have our break. All that really remains of exceptions is for me to go through the notes and, you know, pick out any points that may be important. But honestly, I think we've had a more thorough treatment of exceptions than may actually exist in the notes through this, so, yeah. Good. 15-minute break, 15-minute break. Please be back, well, oh, come on, yeah, okay, I'll give you an extra 2 minutes, just because I'm feeling generous today. Let's be back here for 6:45. Thank you very much. Now recording. So, welcome back. So, before we move on to quick events, let's just make sure that we've covered everything that was important. Yes. Throw, catch. Yep. 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 Here we go. So the stuff that we've been talking about with exceptions so far has been fairly general. In other languages which have exception handling, you'll find things work similarly, even up to and including multiple catch blocks, although different languages will have different specific ways of doing things, of course. You'll find that PHP works very similar to this. Checked versus unchecked exceptions, this is something that's a bit more Java specific. So essentially, all of our exceptions fall, roughly speaking, into two categories, checked and unchecked, just like hockey players. Ha! Jokes. So what makes a runtime exception a runtime exception? It could not be checked before runtime. That is the difference between checked and unchecked exceptions. A checked exception is something that you can check out before your program executes. For example, file not found exception. Java can, as a step before execution, check the file name that you say you're loading, check the file system to make sure it's there, and if it's not, file not found exception, this can be checked. Other things, surprisingly, can't be checked. An excellent example of this is zero division. So, you folks have heard of a zero division error before? Vaguely, yeah. So, question? In regular mathematics, if I say 5 divided by 0, what is the result of that? That's right. Infinity, right? How many, if you take 5 apples and you divide them into 0 portions, how many apples are there in each portion? Infinity, somehow. The real reason is like, if you have a number like 5, the closer, if you have a number like x, and that's the denominator, as x, basically the limit as x approaches 0 of, anything over x is equal to infinity. That's like the shorthand that's happening. So basically, like if you graph it, right, the graph of like 1 over x looks like this. This thing goes off to infinity, but like technically speaking right here it's undefined, right? It's simultaneously, because like 1 over x also like symmetrically happens over here. It goes off asymptotically to negative infinity. So like at exactly 0, is it positive infinity? Is it negative infinity? Who knows, right? It depends on whether you approach 0 from the positive direction or from the negative direction. But generally speaking, when we say 5 over 0 is infinity, what we really mean is the limit as x approaches 0 is infinity, right? A little bit of light calculus for you this evening. But basically, in computer terms, recognizing this problem, computer processors from days of yore have a special circuit built into them to detect when they're about to divide something by 0, and they stop it. They stop themselves, they raise a CPU flag and say, no, that's not allowed. You're not allowed, you're a bad program. Bad program. That's what the CPU says to you, right? But you never quite know if you're going to have that before you actually get there, right? So really, the arithmetic exception, which results from an attempt at zero division, is Java's way of handling a error flag that's raised by the CPU itself, right? So it's basically impossible for Java to predict when one is going to happen. Much as we would love to be able to do that. Basically, it comes down to how type checkers work. Type checkers can check types, but they can't run the program, right? You can't run the program as part of the compile the program process, right? This is what interpreters are attempting to avoid, right? Because you can't run the program as part of the compiler process, because that would result in a compilation process that could literally take forever, right? If your compiler ran your program in order to compile your program, if that program had an infinite loop, your compilation process would not terminate, it would never finish, and you wouldn't get an error message. It would just not ever stop, right? Which is a problem. Actual values aren't tried in your calculations until you actually run the program, right? So that's why there are errors that can't be checked, right? Another good example is actually your good old input mismatch exception, right? That one's perhaps a bit more clear. Input mismatch exceptions happen when users enter bad values. Until the program is run, the user has entered no values. So how could we possibly know if the human sitting at the keyboard is going to enter a bad value at compilation time? It would require knowledge of the future. It would require the violation of causality. If we ever wrote a program that could do that, we are this close to a time machine, right? Does that make sense? Checked versus unchecked exceptions? Some of them are checked, some of them are not. Some things you can know ahead of time, some things you can't. Make sense? Good. Yes. If your code calls a method that might throw in a checked exception, you must satisfy the catch or specify requirement or get a syntax error. This means that you must either catch it or specify in the method header that you want to throw it. So here's another fun little callback to the beginning of the course. So interrupted exception, that's an exception that is that's a checked exception. That's a checked exception. So everybody remembers from the beginning of the course, in order to use thread.sleep, you had to add throws interrupted exception, right? Again, going all the way back to the beginning of the course and making things that were mysterious at the time, perhaps we pull them out of their dark caves of ignorance and throw them into the bold light of day. The reason for that is that when it's a checked exception, Java needs to know what exceptions are possible from this method. It's part of its mechanism that it uses to check checked exceptions. So, thread.sleep is a known problem method. This thing can result in interrupted exceptions. So, when it comes to caught exception, or when it comes to checked exceptions, you either catch that at this level, put that in a try block, that will satisfy the requirement, or you pass that exception up the chain, down the stack. Throws interrupted exception. This line is telling the rest of Java, this method might produce this type of exception. It just so happens that's the same type of exception this thing could produce. So basically, this is our way of telling Java, we're not going to handle this here. You can have it down the stack. We don't care here. Does that make sense? Good. Any questions? Throwing exceptions. Yes. Good. Yep. So, I don't know why you would do it like this instead of doing it like that, you know? Maybe you enjoy pain. Maybe you want to give yourself early onset carpal tunnel syndrome, you know? Which, if you're a Java programmer, is always a present danger. Because there's so much typing. Which exceptions you should throw? So, one exception which you will find to be useful, and when I say useful, I mean useful for assignments and stuff, and stuff might be carrying a lot of weight in that sentence. Illegal argument exception. Illegal argument exception is the exception you should throw whenever the input to a method is outside of what you deem to be acceptable range. Up to this point, we have normally been checking that with an if statement and then substituting a default value if the thing is out of range. Right? This is an okay solution. It does solve the problem of having a thing out of bounds, but it's also being a little bit sneaky because you're taking another developer's arguments that they're giving you and you're saying, that's not good, I'll give you mine. This can cause whoever is using this method to not understand how the code is working, right? Especially if there's no accompanying message, right? It's like, well, I gave it this value, but it doesn't seem to be doing that. It's doing this other thing. I don't know why. A developer should never have to pick through your source code to figure out why your program is behaving the way it is, right? So, if instead you throw an illegal argument exception when you receive an illegal argument, this is something that, this is something that the person who uses your program will thank you for, right? Especially if you provide an informative error message. It's all about informative error messages, right? If you receive a message when you call a function, oh, no, x must be between 73 and 84. It's like, oh, okay, well, I'll just make x between 83 and 74 then. Whereas, if you just, give it 0 instead, it's like, why is it 0? I didn't ask for it to be 0. What's going on here, right? Returning false is also, not a great way of handling this, right? Another way that we've been handling errors so far is to return a Boolean from our methods indicating success or failure. Unfortunately, when we get into PHP, we will be pressed into similar extremes. That's actually the way that PHP likes working. It's not good. The reason it's not good, it's like a principle of modularity. It's violating a principle of modularity. If your method returns a Boolean indicating success or failure, that obligates whoever is using your method to provide it an if statement every time to see that the method worked or not, right? This is adding unnecessary baggage to anyone who's using your method, right? So it's like, the thing you should be shooting for when you're writing functions, methods, this type of thing, is for a person to just be able to use the method, not need any code other than the method call itself to call the method, and for the method to work, right? That's the goal. If you use exception handling, rather than reporting success or failure using booleans, then success is just success. You can assume things succeed unless they fail. If they fail, it causes an error and kills the program, right? Or you can catch the error at some level, right? Like, there's a reason exceptions exist. It's good programming practice to use them properly. Just be careful with them, of course, because when you use an exception, you are, of course, potentially abruptly terminating the program, right? It is awesome power that must be used with awesome responsibility. Don't use them willy-nilly, right? Does that make sense? Principles of good design? Good? Perhaps a brief note on why good design is important in software. So this comes from personal experience. When you are working on a large software project, right? The thing that limits your ability to work on a large software project is your ability to understand the code that's been written, right? So it's very true that when you write comments, you're not just leaving comments for other people. You are leaving comments for yourself in 3 weeks, right? Maybe you've got a pretty good memory, right? But it's very, very probable that you won't remember, the code you were writing 2-3 weeks ago. It's short-term memory stuff, not long-term memory stuff, right? If it was long-term memory stuff, your long-term memory would be completely destroyed by every snippet of code that you've ever written. It's not a good way for the brain to work, right? So, fundamentally, the thing that makes or breaks a large software project over the long term is how well you use things like modularization, right? How well have you broken that software down into digestible snippets, right? If your project gets to be too large, it becomes very difficult to make any modification to it. You sometimes hear developers talk about software projects and like comparing it to the game Jenga. Does anybody know Jenga? Yeah? For those who don't, this is Jenga. So basically the object of the game Jenga, you can sometimes play it with 2x4s. The object of the game Jenga, you have a tower of blocks. The object of the game is to very carefully push blocks out of the tower and then stack them back on the top again, and whoever makes the tower fall over loses. That's roughly the game of Jenga. Software projects end up looking like this over time. Because of kludges, because of people not quite understanding the code that they're writing, because of people not being able to hold in their brain all of the information that's necessary to make a change to the program, right? every bug that's introduced is a hole in the tower, right? By the way, do you know what a kludge is? You should. I will teach you. This is essential terminology for your field. And it's also like my all-time favorite Wikipedia article. Kludge. This is one of my favorite pictures of all time as well. So, this is a kludge. This is the spirit of a kludge. Note that this bridge has collapsed. That is problem. What is solution? They build another slightly smaller bridge over top of the collapsed bridge. Software development often feels like this, right? Kludge defined. An ill-assorted collection of poorly matching parts forming a distressing whole. Especially in computing, a machine, system, or program that has been improvised, bodged together, or a hastily improvised and poorly thought out solution to a fault or bug. Kludges are actually a sign of intelligence. Being able to put one together is actually clever. Right? It requires cleverness in order to do so, and some facility with the language, right? In order to fix a strange bug, one way to fix it is to just kind of work around it, right? Rather than directly addressing the problem, you do something to make the problem go away, right? Rather than actually fix it. Kludge. If you scroll down this article, they think that this is related to like a German word which means cleverness, or perhaps too clever. Like kludges are kind of a way of outfoxing yourself. So every time you fix a program poorly or in a sort of slapdash temporary fashion, you introduce a hole in the Jenga tower. Software projects fail, ultimately, because someone moves one brick too many, and the whole thing has cascading failure, nobody knows what to do about it, and the project's just dead. Nobody can work on it after that, right? Because, like, obviously everything's backed up. You can revert to the last unbroken state, but, it can get to a point where anywhere you touch the code will fail if any modifications are made. This means that code can no longer be modified, which means that the project stagnates and dies, right? So, how do you avoid that? Good modularization and abstraction. All of the object-oriented principles that we have been talking about generously applied, right? We all know that if you wanted to make a version of assignment 5 that had absolutely no classes whatsoever, put the whole thing in main, that might even be easier. Right? You could write one giant interaction to produce all of those TIMS objects. You could write one giant interaction that gathers all the required information and pretends to give you the right output, Maybe you even, you might even create a few classes to hold values, you have an array of things, you store the data in them, but you don't really use them for methods, right? Methods are, do we really need them? Yes, you need methods. Yes, you do. When I was doing my doctorate, I was working on a software project that was basically a compiler. It was actually kind of a cross-compiler between two languages of such extreme obscurity that I would require half an hour to an hour just to explain what they are and do. Which, by the way, is more time than I had for my thesis defense. So, if you want to read my thesis, it's on the internet, but don't. Save yourself for your exam. So basically, I had this code, this project. Throughout my time in grad school, I had worked on it for a period of an actual decade. Like, it actually took me 10 years working with this same program. The program was written in a language called Haskell, which is a language of academic interest, but is not generally greatly used in the general population. It's like mostly for eggheads, because it has a lot of very fancy mathematical abstractions that even very intelligent people don't know how to use. So that project, I started when I was, a gung-ho master's student coming fresh out of a robotics degree, not really having studied software engineering properly. Like, I was, I had done, a fair number of software courses, but quite a few mechanical and electrical courses in there, and never anything approaching good software design. And the decisions that I made in the first couple of months about how my software was to be organized were a curse upon me for the whole subsequent decade. I could not get out from under the bad decisions that I'd made, like literally 10 years ago. And it was awful. It was an awful project. It was like sucked my soul out, because oh man, it's difficult to describe, but the process of if I knew a change needed to be made to that project, it was like the psychological feeling of descending into a dark cave. Like, I literally got PTSD from my own thesis. It was bad. It was like, oh God, if I don't get this software working, at least up to a certain level, I literally have wasted the last 10 years of my life because I'm not going to get the PhD, So, if I had been wiser, if I had known more about software when I started that project, I would have, built it properly from the ground up. Over the course, one of the reasons it took so long is because, I kept finding things out that required me to rip the actual heart out of the thing and replace it with a new heart. The core algorithm was revised 4 times in that thing. And that's would it have needed to be if the software architecture had been, more skillfully done from the outset? Well, probably actually, because the limiting factor there was my understanding of the subject rather than the program itself. But software organization matters. It matters a hell of a lot more than you might think it does. Software projects live and die on how well they've been organized. And so, that's the reason for this course, basically. The purpose of this course is to try to instill in each and every one of you principles of organized software design, because there needs to be some kind of difference between the people in this room who study this as a formal subject and bedroom programmers, right? Maybe some of you started off as bedroom programmers. I applaud that. That shows interest in the subject that you decided to major in college, right? In fact, I would say to be in this program, you probably should have at least, tried to write some programs before you got here, right? Like, otherwise, how would you know you were interested in this, right? But like, the bedroom programmer has never been formally educated in the mechanisms of abstraction. How do you organize large and difficult programs? You folks will have at least some education in that way. That's your advantage over the bedroom programmers of the world, right? So, yeah, that's why this course. Hopefully everybody, wait, that's the assignment. What am I even looking at? Good grief. All right. I did arrays versus lists, right?
Yeah, last
Yeah.
time.
Good. So, array lists. Array lists are very similar to arrays, but they function like lists. I spoke about this last time. Essentially, the reason an array list is called an array list, under the hood, it's implemented in memory as an array, but it presents the interface of a list. It provides a lot of useful methods to do useful operations, which, although the runtime of these operations is lower if you use a list rather than an array list, again, there's like stuff that, like, linked lists are kind of like falling out of favor a little bit, really, in industry, because CPU branch prediction on arrays is way, way, way better than it is on lists, because each node in a list is essentially located in a random point in memory, right? But an array, everything's in a line, so you can make predictions about where the next element is going to be, whereas you can't really with a linked list. So arrays are kind of like, arrays are kind of like, they're rallying against all of the linked list haters. There are interesting things you can do with linked lists, though, that you can't do with arrays. But anyway, I discussed it, I think, last time, or at some previous point, but this thing is called a generic, right? When you have a type that requires another type as its parameter, in Java, the thing that is called a generic right there. So when we declare an array list and we want an array list of strings, we provide string inside of the angle braces. Make sense? This means that array list is a generic type which can apply to any other type. You can have array lists of integers, array lists of any object type. You can have array lists of array lists of array lists of array lists of array lists. Right? Actually, an array list of array lists would be a two-dimensional array list, which is, there is a lot of actual use cases for two-dimensional arrays. Two-dimensional lists. Two-dimensional array lists. Right? Like, for example, checkers. Enough said. So, with array lists, the way that you kind of think about them, you don't initialize them with a size necessarily, right? The idea with an irregular array is you initialize it with a size. We are setting aside this many segments of memory. That's the array. It can never exceed that. An array list is a dynamic structure, or at least it's a static structure pretending to be a dynamic structure, which means that the thing essentially starts off empty. It starts off empty, and you add elements to it as you go. This is probably fairly similar to how things worked in Python with you guys. Do you guys use like an append operation in Python when you guys work with data structures?
No.
So- Oh, well, basically it's empty and you add things to it with add. You know? You can also remove things from it with remove. Remove requires the index of the thing you're removing, right? Get is just like array indexing in the regular sense. So basically, all of your normal operations, you know, if that's how you get a value, how do you think you set a value? Yep. So, it's not completely dissimilar from the, you know, from JavaScript, get attribute, set attribute, those methods. So, that's you know. Let's declare an array. Let's see some code examples and you know. This one I think will be on the shorter side. Main 2, I guess. Man, I feel like the heat and humidity in this room is starting to get to me. You know, I'm starting to get a headache. You know? Or maybe it's just late. And I've been working all day trying to put together a JavaScript exam.
Probably both.
Probably.
Both of those things.
Yeah. So, let's declare an array list. Array list, of strings, I guess. This is equal to new array list. There you go. Why is this syntactically valid? Why did I not have to say what that this is an array list of strings? I already said it. So list dot add, and you can see even in the autocomplete we have been given the correct typing. Not bad. No, you're still running the old one. No, run this one. Go away. Terminate. There we go. Many similar complaints. There you go. Demonstration of list.get1. Or, sorry, get2. demonstration of list.set. Very good. Let's see what toString gives us. Ha! A rare instance. A rare instance where toString does something useful by default. You guys remember how, in order to, oh sorry, let me increase that. Increase the size, there you go. Apologies.
My glasses are a little blurry, that's all.
Hey, I like to think I'm one of those types of profs that actually pays attention to the audience, If I were to choose a way for arrays to print, I would probably choose something like that, right? Or lists or whatever, right? Anybody remember how absolutely disgustingly brutal it was to actually print just the contents of an array during the array unit? Like you had to set up a whole loop just to view the contents. Boom! Array lists. Actually doing stuff that's useful. Here's one for you. What do you want for something?
Do you want the list?
Now I'm just curious. Better. String.compare. Okay, now I'm sorry. I apologize for the brief digression. Lambda expression. A lambda expression. Good. Great. All right. Quick tutorial on lambdas. You guys wanted a quick tutorial on lambdas? Yeah? You guys know arrow functions in JavaScript? Those are lambdas. In Java, they have one stick on the arrow. So, A, B, A dot compare to B. Interesting. You'd think that it could figure that out itself. Very strange. But essentially, the purpose of this is that if you really want to, you can determine your own test, your own comparison test between two things. I wouldn't recommend it. This will probably put us in lexicographic order. Oh, if I print the bloody thing, of course. Yes. This puts us in lexicographic ordering or dictionary ordering. A, J, N, T. Sort. Actually, it'd be interesting to know what sorting algorithm is that in Java? quick sort and then merge sort. Remember those names, quick sort and merge sort. You will be talking about them in data structures and algorithms. Anybody already have any idea what those things are? A little bit? No? A little bit? That's too far a digression. We should pull back.
Yeah, it's too hot in this room.
Yeah,
100%.
I can't with quicksort right now, you know? So if somebody sends me an email though, to remind me to bring my big foam dice to the next class, I'll do quicksort for you. It's always best to demonstrate on physical objects. Yeah, so that should give you a general flavor for what array lists are and do. Many of your typical operations are there. Just take a browse through the autocomplete and see what methods you have available. Now, here's an issue though. When I said that you can make an array list of ints, I was lying. I told a big one. A big fat fib. In fact, you can't use primitive types. You cannot use primitive types. If you put array list of booleans generics are not permitted to be primitives. So, obviously it should be possible to make an array list of integers. That seems like a thing the language should be capable of. So, we have wrapper classes. That's right, folks. When you need an integer, but a primitive type just won't cut the mustard, you can use the wrapper class. The wrapper classes for the primitive types actually contain a fair number of useful methods, most particularly things to like convert them to and from strings. That's where you'll find like double dot to string or double dot parse string, that type of thing. That's where those definitions are held, right? You've got all of your primitive types: byte, short, int, long, float, double, char, and boolean. Each one has an equivalent wrapper class. Make sense? They're set up in such a way that from from a on-the-ground programming perspective, you wouldn't even know you're using a class, right? It just so happens that, these things have a couple of methods attached. You still can't do like 3.toString, though. That still doesn't work. Make sense? So, because of a Java process called auto-boxing, you can act as if the wrapper class is just the same as the primitive type. So, you can declare an array list of capital I integers. Provided a bunch of numbers, it will automatically take these literals and box them inside of their equivalent wrapper classes, because that's what you're asking for. And that's how it works. Make sense? So far, so good? Okay. Now, array lists for multiple association. This is a very short note. When you have a star in your inheritance, what is this, an incorrect answer to test 2? when you have a star on your association arrow, star means, what does star mean? And somebody tell me what star means? Many. It means no defined limit, right? If you have like 0.100, that's perfectly acceptable for an array. You can say, oh yes, of course I can declare an array of 100 for you. Boom, there you go. But star, if we were to declare that as an array, the question that begs is, how big? We can't just declare an unbounded array. What do you think this is? Yes?
So is the star different from the plus that was on assignment 5?
Not substantially.
So they're both like, so the plus is at least 1, the star is many. Is that?
Yes. This is actually, this is notation that you will find crops up again in regular expressions once you get to them. Star means 0 or more. Plus means 1 or more. Pretty much any time it's used to indicate multiplicity. In either event, both are theoretically unbounded. So, array lists are also theoretically unbounded, so you should use an array list anytime you see a star or a plus, right? If you see something bounded here, you should use an array, because arrays are bounded. Does that make sense? Good. Yes. Now, I said theoretically unbounded. Why did I say theoretically?
You only got so much space in the computer.
That's right, you only have so much computer, right? To make an array list that was actually literally infinite, you would need a computer that was also literally infinite, and we only have so much universe to make into computer, although it seems like we're trying to make the universe into a computer as fast as humanly possible. We are literally the replicators. You know the replicators from Stargate? That's what we're doing right now with silicon chips. And you can tell that we are exactly the sort of species that would build the replicators in the first place, because like, to someone who manufactures computer chips, it's like, oh, chips that could make themselves? Oh, sign me up, man. That's a great idea. Oh man. It's so like, give them the ability to make themselves. Can you imagine how much money we would make? We wouldn't have to build plants anymore. They just build themselves. 2,000 years later, it's like that one scene in Stargate where like they land on the planet and they look at the ground and it's just replicators, you know? Okay. This is a replicator. These are 8 alien bad guys from a science fiction show called Stargate. Anyway, it's a good show. It's a good show. You know, probably showing its age at this point, but I don't know, kind of acquired a patina, you know? My goodness. I don't really want to start mouse events with 9 minutes left in class. I will now take motions from the floor. Do I hear a motion from the floor to dismiss class? Yes? You forward the motion? Do I have a seconder? Motion is seconded. Therefore, we must put it to a vote. All in favor of dismissing class say aye. Aye. All opposed say nay. The ayes have it. See you guys on Thursday, Friday? Thursday.
By the way, for assignment 6, the zip thing isn't released. So the assignment's released, but not the zip file.
Can you send me an email to remind me about that?
Sure, yeah, I'll do that.
Thank you. Well, maybe I can. Oh, that sounds like a problem I didn't quite solve.
No, it's okay, I'll send you an email.
Appreciate it.